Welcome to the Bootloader. I'm Paul Cutler.
And I'm Todd Kurt. If you want to learn more about this podcast, visit thebootloader.net for show notes and transcripts, and where you can also find our new newsletter. Paul, 2 weeks ago on the 16th of August was CircuitPython Day. We were honored to be an official part of it with a special live video version of our podcast. You can check that out on YouTube, and we provide a link in the show notes. And I just thought we'd maybe talk a little bit about the experience of the entire CircuitPython Day in our live show. But first, I'd like to say thank you so much for organizing all of that.
Oh, it was nothing.
Not all of CircuitPython Day, but for our part of it was all organized by you. I just kind of showed up, so thank you so much.
It was my pleasure.
The format was we first talked about what CircuitPython had been doing for the last year in terms of its features and updates and how it's in its relationship to MicroPython. We each talked about one project that each of us had done. It was really nice to hear your Song Matrix thing because it straddled so many different technologies because it was a network project that dealt with MQTT and the Shazam API. I don't do much internet stuff with my little electronic devices that run CircuitPython, so it was really cool to see all that and to see real Python working in concert with CircuitPython.
Yeah, that's one of the really neat things about the project. I've got a couple projects that do that, but actually, writing real Python on a Raspberry Pi and then writing CircuitPython and having those talk to each other is that's what excites me about CircuitPython is that those physical devices that you can touch and feel it's just something better than just seeing code on a screen.
Totally. And it kind of reminds me of the synergy that a lot of web developers got when we were able to write JavaScript code that ran in the browser and also JavaScript code that ran on the back end using Node or something. So it's we're getting that sort of that same level of I don't have to switch gears too much because I'm still writing Python, just, different flavors of it. And then my project, I made this 2 weeks before CircuitPython Day, I made this plan that I'm going to design and build and code a little playing card-sized drum machine, and it didn't quite turn out because I made some tiny mistakes. So I've got 10 of these boards, and I'm wondering, should I even fix them up and put them in the store? But it was a fun experiment. I tried doing a similar thing a couple years previous with CircuitPython Day, and that worked out pretty well. And so this was a good learning experience for me. And if anybody has seen this little drum machine playing card thing that I made, if anyone is interested in one, let me know, and I'll see if I can send you one.
And I think it's cool that the project didn't actually work out, and you talked about it. So many projects are, look, I did this, and it just all worked. But that's not how it is in real life, right?
Yeah,
we all
totally.
have challenges, and things break. And it's good to actually show that side of a project.
Yep.
Well, what's your first one this episode for us?
All right. Synthesizers. Have you heard of them? So one of the things that I've been into is modular synthesis. It's the kind of mad scientist synthesizers you might see with all the knobs and lights and all the cables that plug in. And the way this all works is that each little module does one specific part of the whole synthesis process. And so you have something that might make a noise, and then you have something else that shapes that noise's loudness, and another module that shapes that noise's sort of frequency response, like sort of a tone control, and then things that will produce different pitches that control the thing that makes noise. And so it can get really expensive really fast. And so people, when I've talked about modular synthesis, they're like, oh, that sounds really cool, I want to get into it. It's well, it's really expensive to get into if you're not building the stuff yourself, or if you've just decided to sort of this is my hobby and I'm going to sink a couple $100 into it every couple of months, And so if you wanted something else that was not was modular synthesis but was not as expensive, what were your options? It's well, there's some of these software programs out there like VCVRack that will do the sort of virtual on your screen modular synth, and that's actually a really cool way to get started. But it's a thing on a screen, and if one of the whole points of modular synthesizers and physical synthesizers and physical things in general is to get yourself away from screens. And there's also the other problem of if you're trying to build some of this stuff yourself, the things that you will be interacting with, like the jacks you plug cables into and the knobs you turn, those don't work well on a breadboard. Like there's always problems where you're like, as you're turning the knob, the potentiometer will come out of the breadboard because they're just really not made to be plugged in like that. And so what's the solution? And I'd been seeing some noise about this thing called MICRORACK from this Synth get together, the Synth conference called Super Booth a few months ago in Germany. And lately I've been inundated by Instagram ads for its Kickstarter campaign, which I'm like, man, Instagram has me targeted. And so MicroRack is a collection of little PCB modules that plug into a breadboard, just like all these other things we might have that like Adafruit sells, except they are modular synthesis modules. So instead of being several $100s for each little module, it's a little, like each little module does the same functionality as these synth modules, but they just plug in and you wire them together with little jumper wires like you do on a breadboard. And so it's really nice. It's inexpensive. The way you interact with it is very much the way you interact with stuff on breadboards. So if you're used to doing stuff on breadboards, this is like, oh, this will fit right in. And they've got a pretty rich set of modules, it looks like. And they're using the solderless breadboard mostly as a power distribution and a mounting platform, which is great. It's like, oh, here's this very common plastic thing with lots of holes. Let's use it as a mounting board, essentially. I've become a backer of it. I'm gonna hopefully it'll be out. They've been making modules for like 6 months or a year, and they've been showing them off for several months now. And so I'm hoping it's a real thing. It looks pretty real, and if anything, it's going to be a nice way of solving some of these problems of how do I get the knobs to not move around when I'm prototyping something, because I prototype my own little synthesizers on breadboards, and their modules, like some of their modules are just like little knobs that have outputs. I'm like, that's perfect.
Like you were saying at the beginning, I looked into Eurorack a couple of years ago when I had some interest, and it was just so overwhelming. I had no idea where to start, and like you mentioned, the cost quickly went up and up. And I thought about just buying a couple of modules from just Winterbloom and starting there, but I still found it pretty overwhelming. So this is something I might check out. Do you remember how much it was roughly on Kickstarter?
I think for like they've got like a starter kit that's around like $80 or whatever that contains like a good handful of modules. I think the most expensive thing you can get, which contains all their possible modules, is like 300 or 400, which is the cost of one modular synth module if you
Right.
go to a store that sells them. So, in terms of, I think, modules per dollar, it's one of the highest that's out there. I'm mostly interested in it since I developed some of my own little music gizmos. I'm mostly interested in using it as little pieces of potential UI that I will have in my synthesizer. I'll just like use their knobs, use their jacks, that kind of stuff. There have been other similar, let's make some of this audio stuff more breadboard friendly little things that have been out there. I'll put some links to some previous ones in the show notes. One of those famous ones is called Breadboard Friends by Mutable Instruments' Emily Gillette. It's like two of the main problems with the synth stuff on when you're prototyping some stuff is how do you do jacks and knobs? The other one is how do you do power? Because the Eurorack standard is all the signals are plus minus 10 volts. And your breadboard, like everything you do on a breadboard is usually like 3 volts or 5 volts. And
Right.
so it's like one of the main things it solves is how do you make that work?
Very cool.
So how about you? What's your number one today?
I've been talking about building a stand-up arcade for probably 20 years from when I first got a set of ROMs, the actual arcade games you load into an emulator to play. About 5 or 6 years ago, I finally started it. And living here in the Twin Cities, we have a local company called Paradise Arcade who has a focus on the community around fighting sticks, fight stick controllers for fighting games. But they have a wide selection of arcade parts, including buttons, joysticks, and the hardware to hook them all up to a computer. I drove down to their shop, which is more of a warehouse and not a retail shop, which I didn't know at the time, but they were pretty awesome and helped me out. From there, I bought plans on the internet to actually build the cabinet and then bought the MDF to do it. But I've never done woodworking, so this has all been in fits and starts over the last couple of years. I haven't worked on it in a year or two, though I plan to pick it up again in the next few weeks as I have that itch again. The point of the story is if I had to do it all over again, there's a solution that looks to be a lot easier. Pimoroni is taking pre-orders for the Picade Max, a bar top arcade, not a stand-up, that sits on top of a desk or a bar, hence the name. It includes everything you need to build it, just add a Raspberry Pi 5. The kit includes 6mm powder-coated MDF, 2-player controls, and a 19-inch screen in 5:4 aspect ratio, just like original arcade monitors. What's really innovative about the Picade Max are the add-on boards that come with it. There's the Picade Max Power Hat, which powers both the Pi and the screen at 5 volts and 12 volts. The Picade Max USB controller board supports up to 24 buttons and 2 4-way joysticks that connect via USB-C. This itself is a deal, as the wiring harness I bought for mine was about $100 just by itself.
Yeah.
Exactly. And then lastly, there's the Picade Max USB audio board, which has 2 screw terminals for a pair of speakers and is an I2S audio DAC with a 3-watt amplifier and volume control via a separate encoder board. What's really innovative is that these last 2 boards are powered by the RP2040 and connect via USB-C to the Raspberry Pi 5. Pimoroni mentioned in an interview with Les Pounder at Tom's Hardware that they'll be selling these 2 standalone boards in the future, and I know I want to check out the audio board for sure.
Totally.
The Picade Max kit retails for £495, or about $650 with the current exchange rate. That's really not that much compared to how much it would cost to build it yourself, and take it from me. And it's about 50% lighter and not nearly as heavy as using normal MDF to build the cabinet. Of course, I don't want to know what shipping would cost across the pond for that. I'll link to a couple articles from Tom's Hardware with their coverage, as well as the PiCast show on YouTube, where host Les Pounder had Paul and Phil from Pimoroni on to talk all about it.
That's really cool. There have been a few, retro arcade using a Raspberry Pi things over the years, but they've always been sort of, if you can find these random parts that I happen to have in my garage, if you can find the exact clones, then you can use my plans. But having something like this Picade Max could make it really easy just to I'm going to build it this weekend.
Yep. And you do need to set aside time. Paul from Pimoroni joked on the stream that they did that his speed run of doing a complete installation was like 2 hours. And that's,
Oh, wow.
someone who knows what they're doing and has probably done it before. So you need to put a good chunk of time to do it. But then again, it's taking me years and years to work on mine. So this, sounds like it'll probably be a lot faster.
No kidding. Yeah, and I'd love to get the link to the place in your area where you actually got some real arcade hardware, because I used to be really into that. I used to have a couple of stand-up arcade machines. They were old Atari Vector things that were always dying because that was kind of their normal state of things they were in. Once these old games get past a certain age, they're kind of always failing.
Right.
It seems like.
Yeah, and it's really neat. They have everything from PCBs for a couple of games to, mounting hardware to, they custom make some PCBs. And then they've got the whole fighting stick stuff. But I'll make sure to link to Paradise Arcade in the show notes too, because they ship internationally.
Yeah, and the cool thing about the Picade Max being separate boards is you can take some of the Pimoroni stuff and use it with an existing sort of arcade platform that you've already partially built. If you are kind of stuck on the wiring harness problem of how do you get these joysticks and buttons and speakers hooked up to whatever you want.
And I've been worried about sound because just doing the 3.5 millimeter out from a Raspberry Pi isn't, it's still a little tinny. But yeah, I'm excited about that because I really want to check out the audio board. It's got the 2 pairs of speaker terminals, so you can use a real pair of speakers with it, not just some cheap computer speakers.
Totally, yeah.
What's your next one for us?
So...
Uh-oh.
Yeah, well, okay. So at the beginning of August, on August 8th, Raspberry Pi introduced a new microcontroller board, a successor to their popular RP2040 Pico. It's the Pico 2 and a new chip that powers it, the RP2350, which is a great chip. It's like they've improved it in almost every manner. Like it's got a twice as fast dual core set of CPUs in it. It's got extra PIO if you're doing that sort of weird protocol-y stuff. It's got twice the memory. And it's a lower power. Even though it's twice as fast, it's lower power. So it's just all around a really good update. And I've been really excited as I've been slowly getting some of these RP2350 based boards in to test. Since it's twice as fast, and almost all the stuff I do with the chip is in CircuitPython or synthesizer stuff, both of which are really compute intensive. Having a chip that's twice as fast means I can do essentially twice as many synth voices or something, or twice as fast response time. And as I was testing it out, I learned that the capacitive touch library in CircuitPython called TouchIO wasn't working with it. And I started looking into it, found a bug on the CircuitPython GitHub. As I was looking at it with my oscilloscope, I discovered that there's this errata that was in the data sheet called E9 that is a problem with the actual hardware, where if you're using a GPIO pin on this chip in a certain way, mostly as an input, it will latch up and stay at 2.2 volts instead of like high or low. And so the capacitive touch sensing works in CircuitPython and a lot of other systems is you have a pin and it drives that pin high for like 10 microseconds, and then it turns that GPIO pin into an input and watches how long it takes for that pin to go low. And that time that it takes is basically it's discharging the capacitance of whatever the line is connected to, like a little capacitive pad. And when you human touch that pad, that changes that capacitance. And so the time it takes to go from high to low changes. And so with that, you can get a really good sense of like, oh, has something touched the capacitive pad or not? But because of this pin is sort of like staying high, or not staying high, it's staying at 2.2 volts, which is kind of not quite high, but it's definitely not low. It means that touch IO doesn't work. It also means that certain kinds of button inputs won't work either, that have like certain low or certain high of resistance pull down resistors, or if you've configured internal pull downs in the chip. And so I'm at this point, I'm not recommending people use the Pico 2 or the RP2350 if they're newbies, because it's got this weird input problem where you don't know, is it not working because of my wiring, or is it not working because of you're tickling this weird input bug on the chip? And thankfully, Dan Halbert, who's a core CircuitPython developer, he looked into it in much more detail than I, and he's created a bunch of really good test cases that he's opened issues up on the Raspberry Pi GitHub and on the MicroPython GitHub. And so there's a bunch of good data, and the relevant people have been notified. So hopefully there'll be a fix. I don't know if there'll ever be a software fix. We might have to wait for the next version of the Pico 2 chip to come out. But if you want to read more about this, Hackster wrote an article about it that talks a bit. I think they downplay the problem a bit, because I think the problem is actually more of an issue than some people say. It's like, oh, it only happens if you have internal pull downs enabled, But no, I think it's a problem anytime you're doing any kind of input with high resistance pull downs on the output. Which, if you're doing low power work, if you're doing certain kind of bit bang protocols like I2C, if you're doing those by hand, that require an external pull down resistor. So yeah, just be warned. There'll be lots of links in the show notes about all this if you want to look into it more.
Yeah, it's disappointing to hear on such a popular chip, right at the beginning to run into a showstopper bug like that. Does
Yeah.
it occur on all the pins, all the GPIOs? Or
Yeah,
just
yeah,
Oh, okay.
yeah. I mean, I think maybe the ADC pins in some cases are it doesn't affect them because the sort of the analog buffer gets like turned on instead of the digital GPIO buffer. But all the digital pins definitely. Yeah, pretty frustrating. I think most people won't see a problem, but I've seen a problem with buttons, and I've seen a problem with the cap touch.
Which is one of your favorite things to do.
Yeah, no, it's like I was like, oh, I'm gonna just like use this as a drop-in replacement for some of my existing boards on Tindy, and nope.
Just kidding.
Yeah, lol. So yeah, what's your number 2 this week?
I've mentioned a couple times on the show that I have a 3D printer from Bambu Lab, and they're back in the news again after Stratasys has sued them for patent infringement. Stratasys created 3D printing back in the late 80s, and through that and their acquisition of MakerBot just over 10 years ago, hold most of the patents related to 3D printing today. I've linked to 2 articles from Ars Technica and Tom's Hardware that have really good coverage in the show notes that go into far more detail than I will. In question are 10 patents, and 2 jumped out at me: the heated build platforms and purge towers. Both of these are pretty standard in 3D printers, which raises the question, are their patents still valid, or is there prior art that may invalidate the patents? Phil Terone of Adafruit asked this question a few weeks ago when this hit the news. He suggested that someone like the Open Source Hardware Association should start a database to catalog prior art to see if the patents could be invalidated. I'm wondering if it actually needs to be a database, or could prior art be tracked in something simpler, similar to an awesome list? in simple markdown on a GitHub page, for example.
Totally.
I'm half tempted to start a list myself, but I don't think I have the contacts in the industry to get the list right. This isn't the first time a prior art search has been done against Stratasys' patents either. Doing some search engine queries prepping for the show, there were calls just over 10 years ago for prior art to fight some of these patents, but I couldn't tell if anything ever came out of it.
Yeah.
I'll link to the articles that I mentioned with coverage of the story in a Reddit thread with some speculation about why Stratasys is going after Bambu Lab and not other companies. And again, it's just speculation. You know, I'm not going to say they're conspiracy theories; they're just theories. But it probably just comes down to the fact that Bambu Lab has had a large amount of success in a very short amount of time, and they're afraid of losing market share of their large commercial 3D printers to an upstart consumer 3D printing company.
Yeah, there's I've heard so many patent issues with Stratasys. Like, I mean, one of the things I think that started the whole consumer 3D printing revolution back in 2000, was it 6 or 7, was that one of the key patents that was about I'm going to melt plastic and squirt it out into using a CNC controlled nozzle, that went out of patent in like the late 2000 or the mid 2000s or something, and thus we got RepRap, and then when we got MakerBot and Prusa and all these other pretty much every 3D printer is because of this patent being finally expired. And I remember hearing one of the reasons why a lot of these consumer 3D printers don't have heated build chambers is because Stratasys still had the patent on heated build chambers, since everyone just had heated platforms. and then and people would say, well, if you put your heated platform 3D printer in a small box from IKEA,
right,
your prints would be much better.
Stratasys headquarters is about 15 minutes from my house here in the Twin Cities, and I'm just half tempted to drive over there, knock on the door, and go, "What the hell are you doing?"
What?
But obviously, they look at this as defending their patents and their revenue stream, so I see both sides of it.
Yeah.
But it's still very frustrating for things that are very common today to still have patents against them.
Yeah, super frustrating, especially for things that seem pretty obvious. But this is kind of the world we have to play inside of, I guess. So.
And I did look; a number of those patents don't expire till like the mid 2030s. So it's there's still over 10 years to go on some of them, which is quite a long time.
Yeah. Well, cross fingers that we'll find a way.
Well, that's our show. Thank you for listening. Visit thebootloader.net for detailed show notes, transcripts, and to sign up for our new newsletter. If you like the podcast, you'll like the newsletter, as we give you some behind the scenes and some extra links that we didn't cover in the show. And we promise there's no spam, no tracking, so check it out. Thanks for listening, and stay positive.